Moving on now to Chapter 5, we're going to start with Lesson 5-1. This entire chapter is entitled Inequalities, and 5-1 is talking about properties of inequalities. And so I know that there's a lot, but they will pretty much mirror, at least for the most part, the properties of equalities that we did back in Chapter 2. So if you want to take back a look at those. But again, those were those key things that we quoted as we started doing different proofs. And so hopefully by the end of this, you can be able to say that you know the 8 properties of inequalities, which is the 3 possibilities, the transitive, the addition theorem of inequality, subtraction, multiplication, division, and then the whole greater than part theorem. Now, most of those you should possibly recognize, but there's a couple out there, like the 3 possibilities, the addition theorem of inequalities, and the whole greater than part theorem that we'll be going over. So please make sure that you're getting these down in your notes, because these will become important once we get down to the actual proofs. Let's start off with just kind of some easy ones that make sense. The addition property of inequality basically states that if A is greater than B, and if I add C to both sides, that just still means that the left side is greater than the right side. Vice versa. Alright, subtraction. If A is greater than B, then A subtract C will still be greater than if we take C and subtract it from B as well. So again, it's just kind of that whole idea of a balance, being able to take away something from one side or adding something to one side and doing the same exact thing to the other side, that the inequality will still remain true. Obviously, as you probably could guess, multiplication property, so same kind of idea. So A is greater than B, and in this case right here, C has to be greater than 0. Then A times C is greater than B times C. Now, if C is equal to 0, well, then that means that both these are 0, which means that 0 is not greater than 0. And if C is negative, then you would know, let's say A is equal to, say, 3 and B is equal to 2. Well, then all of a sudden over here, if C was equal to maybe a -1, then it would mean that -3 is greater than -2, which we know is not true. So that's why we have to say that C is greater than 0. Same thing with division. So if A is greater than B and C is greater than 0, then A divided by C is greater than B divided by C. Same type of reason why it can't equal 0 and why it can't be negative. The 3 possibilities kind of makes sense as you go through it, but again, either A is greater than B, A is equal to B, or A is less than B. Makes sense that basically in any of these possibilities, either a number is greater than another number, equal to it, or less than it. And the transitive property is similar to the substitution property, but deals specifically with just the inequality. So again, think about the substitution property, that if I knew that A was equal to B and B was equal to C, well, then I knew that A was equal to C. Well, now with the inequality, if I know that A is greater than B and B is greater than C, then A is greater than C. And again, kind of thinking about if A is better than B and B is better than C, well, then that means that A is better than C, say at a sports. Like I remember my boss talking about how he is better than Nadal, and this is his proof, is basically back when he was in high school, he was a senior in high school, and there was a 7th grader coming through, and my boss, my coach, basically beat this 7th grader. His name was Eric Buderak. So if A is my coach and B is Eric Buderak, my boss at one point beat Eric Buderak. Then later on, Eric Buderak beat Nadal in one of his matches that he met up there. Rafael Nadal. If you don't know tennis, all right, it's he's one of the best players in the world. And so then my coach can basically sit there and say that because he beat Eric Buderak and Eric Buderak beat Nadal, then my boss obviously is better than Nadal at that point. The logic doesn't make sense in anybody else's mind but his own, probably. The addition theorem of inequality. So kind of a combination of the addition property that we talked about earlier. But if A is greater than B and C is greater than D, then I know that if I add A and C together and I add B and D together, well, I know that A plus C is going to be greater than B plus D. It's kind of the idea that, okay, so if A is a really big number and C is a really big number, and I add them together, it's going to make it a big number. Whereas B is a little number and D is a little number, I'm going to add them together, and no matter what, we're not going to be able to, because these are both little numbers, it's not going to overshadow the bigger numbers as we add them together. So if it doesn't make sense, try to plug in some numbers like 4 and 3 and 6 and 5. So 4 plus 6 is 10, and 3 plus 5 is equal to 8. So 10 is still greater than 8. And then the whole greater than part theorem, which is kind of a little bit more complicated, but it states if A is greater than 0 and B is greater than 0, and I know that A plus B is equal to C, well, then I know that C is greater than A and C is greater than B as well. This idea is basically, again, if you need help, plug in some numbers to be able to figure out that basically, again, A can't be 0 because then B would be equal to C, and B can't equal 0 because then A would equal C, which then contradicts this. Or negative numbers would mean that C would then become a smaller number. What we're saying is basically A is a positive number, B is a positive number. If I add them together, say, we'll take the 4 and 6, again, make 10. That basically, because we're adding together positive numbers, then that means that the total of it is greater than the two parts of it that make it up. So the whole, which is C, so for our whole, is greater than either of the parts added together on that. And we'll talk about that more in class later on, but just make sure you get that down as you go through. But try to think about it a little bit. And lastly, I'm going to leave you with just kind of a couple examples of what we're going to see in the book. So again, name the property illustrated below. This is kind of the same thing that we did in chapter 2. But if I know that x is less than 4, then I know that 3x is less than 12. So the question is basically, what am I doing to this one here to basically manipulate it to get it to here? Hopefully you're saying to yourself that you're multiplying by 3, and so you would quote the multiplication property. If a squared plus b squared is equal to c squared, then b squared is equal to c squared minus a squared. A little bit different, but again, think about what I did to the left side here to go from a squared plus b squared to just get b squared. And then think about, okay, so now I have a c squared here, and all of a sudden I'm subtracting a squared to it. So hopefully you're thinking in your head that basically you subtracted a squared from both sides, so you then would quote the subtraction property. And then last but not least, either x is greater than 2, x is equal to 2, or x is less than 2. For whatever x you put in there, hopefully that's starting to sound, if you take a look back at your properties, knowing either it's greater than, it's equal to, or it's less than, you should be able to then quote the 3 possibilities property as you go through. So please make sure you get these notes down. I'd like to see those. And then we will start working on some more stuff tomorrow. All right, thanks, and have a great day.